of Science and Technology welcomes our guest for the day, Professor Sateesh K. Peddoju, Professor at Computer Science and Engineering Department of IIT Roorkee. He is having more than 25 years of experience, the senior member of ACM and IEEE. More than 15 research scholars are working under the guidance of Professor Sateesh. He has published various research papers and books in journals of high repute. He is reviewer to many journals and has presented many papers internationally. His research areas are cybersecurity, cloud computing, and pervasive computing. He is doing several research projects and consultancies. He is recently awarded with Best BTech Project Award and Best DIC Internship Award. Today he is going to talk about edge computing. We are providential to have you as our speaker for the day, sir. My gratitude to you for accepting our invitation to deliver this talk in this FDP on such a short notice.
Hello, am I audible to you?
Yes, sir.
Yes,
Sir,
you are audible. Kuldeep, are you able to listen?
Hello.
You
Yes,
can
sir.
continue, sir.
Okay. So good evening, everyone, and good evening, Dr. Kavita, for inviting me for this wonderful session. So
Thank you, sir. Thank you
thanks
so
for
much.
the introduction as well. Give me a minute to pull the slides and connect to this lecture Zoom. Okay.
Please.
Dr. Kavita, this sharing is not having screen sharing option, right?
Kuldeep, please resolve the issue. Sir is not able to share his screen.
Kavita, I am calling Kuldeep on his mobile phone.
Okay, sir.
Just 2 minutes, sir.
Yeah.
सर आई थिंक आप एक बार लीव करके मीटिंग को और फिर से रीजॉइन करेंगे तो द प्रॉब्लम विल बी रिजॉल्व्ड आई गेस.
हाँ बिल्कुल ये ऐसे ही करना है. सर प्लीज लीव द मीटिंग एंड रीजॉइन इट. नाउ यू हैव बीन मेड को-होस्ट. वो ऑप्शन आ जाएगी सर आपके सिस्टम में अभी.
प्रोफेसर सतीश. यस.
आई थिंक ही हैज ऑलरेडी लेफ्ट.
यस सर.
रीजॉइन करेंगे तो वो ऑप्शन अपने आप आ जाएगी.
कर लिया सर उन्होंने रीजॉइन.
ठीक है.
Kuldeep, now make him co-host. Kuldeep, now make Professor Satish co-host, please.
He is already co-host. I can see it.
Okay, sir.
Professor Sateesh, now try to share the screen, sir.
Yeah, please.
So we are able to see your name as Sateesh Kumar. What is the name of another machine so that we can make you co-host?
I think it is also Sateesh Kumar Peddoju.
Yes, sir. You have joined with the two machines.
Yeah. One with without photo, one with photo.
सर वेट मैं बना रहा हूँ सर एक बार को होस्ट 1 मिनट के लिए अभी बना रहा हूँ सर
कुलदीप दोनों को को-होस्ट बना दो
यस सर दोनों को बना रहा हूँ सर दोनों को बना रहा हूँ
Okay. Gaurav, can you mute your system? Gaurav Indra.
सर नाउ चेक हेलो
Yes,
यस
Kuldeep.
सर हेलो यस
Sir
सर
is
बना
there
दिया
in the
सर एक बार चेक करो
Thank you. Let me try.
थैंक यू सर
पानी देने के लिए कहा था
No, अभी भी वो सेम में से only host can share in this meeting.
सर मैं आपको होस्ट बनाता हूँ आप भी चेक करना सर मैं आपको
सर
होस्ट
तो
बनाता हूँ
होस्ट बना दो हम को होस्ट बन जाएंगे
हाँ कौन से पे बनाऊँ सर कौन से पे बनाऊँ
कोई से पे भी बना दे एक पे
ठीक है सर ठीक है
SK लिखा हुआ है जिसपे ग्रीन
जिसमें मेरा फोटो है उसमें बना दूं
ठीक है सर ठीक है जिसमें आपका सरनेम है लास्ट में
दोनों में
फोटो लगा हुआ है जिसपे एस की
सरनेम
जगह
तो दोनों
फोटो
में
लगा है।
कुलदीप सरनेम तो दोनों में है
हाँ
जिसपे
ठीक
फोटो
है सर चलो दूसरे में बनाता हूँ सर
फोटो जिसमें है उसमें बना देना
ठीक है सर एक पे तो SK लिखा हुआ है दूसरे पे बना दो जिसपे सतीश कुमार पेड्डूजू जो है जिसपे
सर एक
फोटो
बार
भी है
इसमें
सर
अभी चेक करो सर
कुलदीप
एक बार अभी चेक करो अभी चेक करो
हाँ मगर बन
यस सर चेक करो सर अभी एक बार
शेयरिंग का ऑप्शन तो आ रहा है लेकिन इसमें स्क्रीन
अभी
शेयरिंग
चेक करो
का
सर
ऑप्शन नहीं आ रहा है
नीचे हमारे पे तो आ रहा है सर वी आर
सर मैंने आपको होस्ट बना दिया
सर हम को
सर मैंने होस्ट बना दिया सर आपको
चलो ठीक है
कोई बात नहीं
दूसरे
सर मैंने होस्ट बना दिया सर अभी
ठीक है
हेलो
एक
सर होस्ट बना दिया अभी
ठीक है कुलदीप
एक बार
हेलो
चेक करो सर
आवाज आ रहा है
चेक करो सर
सर यू आर ऑडिबल सतीश सर यू आर क्लियरली ऑडिबल
ओके राइट लेट मी डू वन थिंग
स्टार्ट ही नहीं
कुलदीप आपकी स्क्रीन शेयर हो रखी है
नहीं सर मेरी कोई स्क्रीन शेयर नहीं हो रखी है सर
FDP आ रहा है मेरे सिस्टम में मैंने स्पीकर को पिन कर रखा है और FDP लिखा आ रहा है अब आ गया सतीश कुमार सर का आ गया नाम लिखा हो नाम आ रहा है लेकिन स्क्रीन और कुछ नहीं आ रही
भी कर रहे होंगे सर एक बार चेक करने हैं क्योंकि मैं तो कब होस्ट ही नहीं रहा
अच्छा जो शेयर स्क्रीन वाली ऑप्शन है ना कुलदीप
यस
उसमें
सर
मैं देख रहा हूँ उसमें 3 ऑप्शन है 1 पार्टिसिपेंट कैन शेयर एट अ टाइम मल्टीपल
yes, sir.
पार्टिसिपेंट्स कैन शेयर साइमल्टेनियसली और एडवांस्ड शेयरिंग ऑप्शन, वहां पे चेक करें क्या सर कुछ?
एक बार सर से पूछ लो सर। अब तो होस्ट बना दिया ना, अब तो आ जाना चाहिए। अब तो हमारे पास कोई राइट ही नहीं है।
मैं देखता हूँ।
Sir, please confirm if you are able to see.
Yes, sir. Sir, it is starting. You have started your system. It may take a few seconds more. Sir, you are sharing with the machine where your photo is not there.
Yes, correct.
इस मशीन पे आप को होस्ट हो सर, जो दूसरे वाली जिस पे आपकी आइडेंटिटी कार्ड वाली फोटो है उस पे आप होस्ट हो।
हाँ।
उस मशीन से शेयर करोगे तो हो जाएगा सर।
सर उसमें प्रॉब्लम क्या है? उसमें ये
इससे भी हो जाएगा सर, इससे भी हो जाएगा, इससे भी हो
हाँ।
जाएगा सर। हो रही है अभी, ये चल रहा है।
कुलदीप
हो
अभी
रहा है अभी,
या
एक
तो
मिनट
फिर
वेट करो सर बस।
हाँ कोई इशू है इसलिए हो रखा है। बाकी ये मैसेज आ रहा है, सतीश कुमार हैज स्टार्टेड स्क्रीन शेयरिंग।
हाँ मेरे पास भी यही आ रहा है सर, स्क्रीन शेयरिंग। फाइल कोई ज्यादा बड़ी तो नहीं है ना?
नहीं वो तो पीपीटी ही है। यू आर और तो क्या?
ये पे बैंडविड्थ थोड़ा लो हो सकता है सर।
बैंडविड्थ लो है इसलिए थोड़ा चल रहा है काम। सर के एंड पे थोड़ा प्रॉब्लम हो सकती है। हम शेयर करके देखें कुलदीप, इतनी देर में थोड़ा टेस्टिंग ही हो जाएगी।
हाँ देख लो सर, आप को होस्ट हो, आप देख सकते हो।
कुलदीप मेरी स्क्रीन शेयर हो?
यस सर, आ गई आपकी स्क्रीन होस्ट, आपको आ गई बिल्कुल।
मेरी
कोई
स्क्रीन
प्रॉब्लम नहीं है
होगी
सर, आपकी
शेयर?
स्क्रीन आ गई। आप जूम, आपका जूम। यस सर जूम का खुला हुआ है
आपकी
आपका
स्क्रीन
पेज,
शेयर
वेब
हो
पेज
रही है
खुला हुआ
सर।
है।
ठीक है, मैं इसको बंद कर देता हूँ।
सर की ईमेल से पीपीटी मंगवा लो कुलदीप, आप लोग ही कर लो मैनेज।
मैडम मैंने तो मोबाइल से किया हुआ है, इसलिए मैं
मैं
कहीं पे
मंगा
हूँ,
लेता हूँ, मैं
यहाँ पे
मंगा लेता
बैंडविड्थ वैसे ही नहीं है। हाँ सर, आप उस पर लगा लो। मैं आपको होस्ट बनाऊं सर फिर?
हूँ। मेरे को
सुदीप सर, हाँ आपको होस्ट बना देता हूँ।
सर आप देख लो अभी आ रहा है क्या?
सर
सर
ये आ रहा है
यही आ रहा है
सतीश
सर,
कुमार हैज
हाई
स्टार्टेड।
स्टार्टेड।
स्क्रीन शेयरिंग आ रहा है अभी तक। सर एक बार स्टॉप करके फिर से ट्राई करना
एक बार स्टॉप करके रीस्टार्ट कर लो सतीश सर।
अब हो गया सर?
सर नहीं, अभी भी वही
सर
ब्लैंक
हैज
स्क्रीन पे।
स्टार्टेड स्क्रीन शेयरिंग आ रहा है।
सर एक बार रीस्टार्ट कर लो आप मीटिंग को। कुलदीप
डिस्कनेक्ट करके सर दोबारा कर लो कनेक्ट।
कुलदीप तू तो
सर एक बार
आप ही कर लीजिए,
सर की
स्क्रीन
जो
शेयर आप ही कर
एसके
लीजिए,
वाली
पीपीटी आप ही शेयर कर लीजिए।
सुखदीप सर, आप मेल मंगवा लो सर।
ठीक है
अब कैसा है सर? अभी भी नहीं आया?
सर। अभी
नहीं
भी
सर।
अभी भी सेम है सर।
अब होगी
सर आ
सर।
गया, सर आ गया।
यस सर, आ गया सर,
हो गया?
आ गया।
हाँ
यस
हो
सर,
गया
नाउ
सर
इट्स
शेयर।
विजिबल।
यस सर।
सर स्लाइड शो स्टार्ट कीजिए सर, ये विजिबल है अभी आपके जो स्लाइड्स हैं।
अभी
सर
स्लाइड पर
ये होस्ट से की है, को होस्ट से की है?
अभी स्लाइड शो नहीं है मैडम?
सर स्लाइड्स दिख रहे हैं, स्लाइड शो नहीं हुआ है। योर स्लाइड्स आर विजिबल।
Oh, what is this? I think it is already in slideshow.
Sir, it is visible. It is visible. You can continue with it. Sir, let us start the topic. It is visible.
Is it the full screen or this one?
It's not on the full screen, but still it's visible. It's readable.
How about now?
Same, sir.
Same.
I think there is a bandwidth issue with the.
Were the slides changing or not?
No, sir. We are on the first slide.
You're on the first slide. So what about now?
So still we are on the first slide.
Surprise. What could be the reason? Like, I don't understand.
Sir, low bandwidth may be one of the reason, and heavy size of the slide, this file.
Is it okay now or not yet done?
Yeah, it is visible, sir. We are seeing the first slide, edge computing.
Yes,
now
sir.
second slide.
Slides are changing. Yes,
So
sir.
it
Now
has started.
Okay. And is it in notes format or like full screen format?
no,
It's
not in the
notes
full
format.
screen.
Full screen. Okay.
No, not in the full
So
screen.
not
sir.
in the full screen, sir. It is in the
Okay.
notes format.
Oh. What is the reason? Is there any way to swap this?
Sir, we can continue with it. It is clearly visible.
Acha, is it? Okay.
Yes, sir. We are in the second slide now.
Okay. Let me see if things can improve.
Yes, sir. Now it's full screen.
Full screen, right?
Yes, sir.
Yes, sir. Yes, sir. Now it's full screen and we are on second screen.
How about my audio? Is it
Yes,
fine?
sir.
Sir,
Yes,
your
sir,
audio
it's
is
very
clear.
clear.
You can continue with the discussion, sir. Now it is visible also.
Thank you so much.
Fine, sir. Fine.
As participants, this little inconvenience is regretted. I hope you are there in the meeting.
Yes,
So
sir.
we can
have
continue the discussion.
Yeah. So do you see me also?
Yes, sir.
That's great. Thank you. Finally, we have done it. Yeah. So good evening, everyone. I'm very, very sorry for this delay. I don't know what could be the reason, but somehow it created some chaos. Not to worry. Yes. So the topic is edge computing. Professor Kavita, can you please confirm if anyone has already covered this topic earlier, some basics or something like that, or what is the status of this talk?
No, sir. Nobody has talked about edge computing.
Achha. Some basics of IoT?
Yes, sir. Basics of IoT and smart cities were there.
Okay.
One professor from CSE department and two from architecture department has given talk in first 3 days.
Okay. Okay. So then I will try to speed up the discussion. A little slides are there on IoT as well to introduce. And yeah, later I will quickly jump into edge computing. So yeah, this talk will cover the basics of IoT, and it will also introduce the concept of cyber physical systems, and also it will introduce the word edge computing. So that is the goal of today's talk. Yeah, so there are a couple of technological developments day by day going on, and these days we are seeing the development in such a way that IoT is occupying every corner of the individual's life, and these are a couple of interesting examples that contribute for IoT. And like in this picture, you see that the showers are becoming smart, and like they play the music, they dance the water according to the music, and like that you can restructure, redesign the environments as per the user's interest. You can also think of smart mirrors, where you can precisely make up yourself, or precisely identify the faults in your face, and you can actually figure out the fixing methods. Probably you can also figure out, maybe the mirror will give you the advice to you how to address these kind of problems. Yeah, this is another example for smart mirror, where you can have the precise makeup, right? And this is a third example for the same mirror, but this time it is used for smart shopping purpose, where it is acting like a mirror as well as a computing machine, where you can basically place the orders, and you can use that mirror as your what is called test room, where you can test all your purchases visually, virtually, like for its color, for its size, for its model, right? So several purposes you can actually use it as a trial room, and you can place the order from your home, and much smoother and easier way compared to and much accurate way compared to the current online placement mechanisms. Okay, and you can make your home smart. Like this is one small component. We talked about two examples. First example, the shower. The second example, mirror, and both are in your home. And in the similar fashion, you can talk about several similar examples where your TV, your lighting systems, your air conditioning mechanisms, your security locking and security mechanisms, right? Your TV and your plants, everything can be made smart, and you can operate all of them through your mobile phone. You can switch on the lights whenever you want. You can switch off the lights. You can switch on the air conditioning systems. You can switch off them whenever you want, right? And in the similar fashion, you can actually utilize the smartness or intelligence of systems through your you can operate these intelligence of these systems through your mobile phones. And over the period of time, now we are seeing your TVs are earlier operated with your remote systems, and probably earlier it was manual, then remote, then you even operate with them with your mobile phones. But nowadays you don't even need all this equipment. Just your hand gestures are sufficient to operate your television in your home. So you can play the games with your, don't need joystick, you don't need remote, you don't need any mouse or anything as such, keyboard. Just use your hand gestures to play your games. Such a sophisticated systems are coming up, and all this is just because the advancements in your IoT developments. So we have seen 2-3 examples only so far: shower, your mirror, right? And all other components in your home, including TV. And now these are much more bigger set of examples. Like, you can talk about making your entire home smart, including your using gas leak sensors, smoke sensors, light switching, air conditioning, right? Rain sensors. There are many examples in your home itself that can be made smart. Your blinds, smart windows. So like that, you can talk about hundreds of examples, thousands of examples just within your home itself, which can be made smart. Okay. And think of a day where you are having such hundreds of systems provided in your home, and all of them are producing huge amounts of data, and you need to operate on this data. You need to store this data. You need to process this data from your those sensors, typically the Raspberry Pi controllers or any other controller. Most of the times, smart home systems use very small set of so they use typical controllers to operate on these systems, and they don't have bigger computational capacities. Or like, for example, if you take Node MCU, it's very cheaper one, and it's not having any big computational power or any big storage power. Even memories are smaller, and that's the reason why processing the data, managing the data locally is almost like impossible. Okay. So in such hundreds, thousands of IoT based systems in a single home are producing huge amounts of data. So you need a mechanism to store all this data at some place, and process that, and produce some outcomes, or you can say alerts, generate some alerts, or try to predict future events. Many things can be done, right? And this is where we talk about alternative storage mechanisms, processing mechanisms. And one of the top most storage and processing mechanism is your cloud. Okay. So anyhow, we'll come to that. So a quick summation is that as far as smart home systems are concerned, United States is very far ahead compared to other countries, and India also, the adoption is pretty much low, and only a couple of states or cities are basically adopting the home automation systems. So though the adoption rate is too slow and too low, so obviously it takes little time for all the systems to come into the market and occupy the the smart homes. But by the time you get huge amounts of these IoT systems and they produce the data, you need to have mechanisms to speed up the systems. Okay. And in the similar lines, we talk of several other examples like smart cities, and many people must have already talked about smart cities. And the basic idea is to provide the safety, financial, and environmental benefits in the form of reducing the congestion and lowering the fuel usage, or maybe power and cost savings, or maybe revenue, providing the efficient services. These are all different advantages we get with the help of smart cities. So if you talk about a city, then one small home now is getting connected to large number of thousands of hundred thousands of houses across the city, and all the other services connected with this within this city, including your traffic, including your parking services, lighting services, and many other drainage systems, and many other things come into the picture. Okay. And same is the case for transportation. And we talk about passenger security, route optimization, and the way with which we will create actionable intelligence so that we can avoid the accidents as much as possible. So the goal of smart transportation is to provide highest safety and superior services while providing the cost savings. Yeah, other best example in this direction is smart grid. And yeah, there are many advantages over the smart grid systems as well. And I will not spend much time on this. Just to want to give you a hint that they provide improved reliability, efficiency, power quality, security, and many advantages are there with the smart grid systems. So these are all typical advantages of IoT systems. And in the similar lines, if you go on listing such healthcare is another big advantage, application of your IoT systems. Agriculture, transport, we have already seen. Yeah, manufacturing is yet another big application of IoT systems. And nowadays we are talking about the new term, Industry 4.0. See, that's how IoT has impacted. And if you see the government of India, investment, there are there are almost all top IITs are having cyber physical systems, what do you call, centers, technology innovation hubs, which are producing large number of IoT centric and cyber physical system centric products. Yeah, shopping and home automation, many other things are there. And whatever you think of in your daily life, that thing can be made smart. The smartness comes through adding of artificial intelligence to that thing which is not actually having any self-intelligence. Okay. Yeah, so the big point is the IoT devices are growing drastically. The adoption of IoT devices is going drastically, and it is almost like equal. 7-8 times it has already crossed to world population, and is going beyond it. And soon we may see on an average per head you will find 25 smart systems per human being. So that itself says that how much penetration of IoT systems are there. And the big point out of it is that the data, how much they are producing, is also important. So the more the number of internet connected devices, the more the number of IP has to be there. And these devices are producing a lot of data, and this data has to be stored, managed, processed, like many things you need to do with that particular data. So Manisha, can you please mute yourself? Yeah. So Kevin Aston in 1999 introduced this word, and later.
All the participants are requested to kindly mute themselves. I'm really sorry, sir.
Let me see if I can mute her.
Sir, she has muted herself. We can continue with it.
Okay, all right. There is another one, Anu, I think.
Anu, yes, I will mute her.
Okay, right.
She has muted herself.
Fine. Thank you so much. All right. So later, this word has become very popular, and over the period of time, it has become a standard. Internet of Things word has become standard. And just I will quickly emphasize the terminology here, that Okay. Are you able to see the text here? Is my figure
Sir,
upstairs?
yes, sir. Definition of IoT.
Yeah. Okay, fine. So the Internet of Things is a self-configuring and adaptive system that itself shows some sort of intelligence is there within them. They have to manage themselves by virtue of some intelligence, and they have to adaptively work. So these are the two important terms which shows are how they function and what is the intelligence that makes them self-configuring and adaptive. Otherwise, it is just a network of sensors connected with smart objects. These smart objects are typically the physical things connected with some sort of intelligence. Okay. And they are intelligent, programmable, and more capable of interacting with the other things or other humans also. So that is a preliminary idea of IoT systems. And slowly this idea elaborated to several other concepts over a period of time. Yeah. So typically every IoT system will have source, sink, and actuator. Actuator is a kind of device that makes that alerts the users in the form of actions. So every IoT system is expected to have basically I cannot write on this, right? Okay, right. All right, no problem. In that case, let me use the pen.
So there is an option of whiteboard at the bottom of the screen.
Yeah, no worries, no worries. So it is having a set of sensors, and typically this is connected with some sort of storage media, typically the sink, which stores the data produced from the sensor, and this needs some connectivity from sensor to the cloud through some gateway, and that gateway could be your mobile phone also. Okay. And after the data is stored in your cloud, you may store it or process it, or you may analyze it or produce some alerts, or some actionable intelligence can be done. So these are the four important technological linkages. First is IoT, and mobile technologies, cloud, and big data analytics are the four important technologies basically which are really needed in the context of IoT. And most of the times all the three will be there, and if not, at least excluding mobile, rest three will be there in your IoT centric equipment. And there are some examples which are basically directly sensors connected to they are having their own local storage power, processing power, memory, and they themselves get connected to another IoT system. So it's possible that one IoT system to another IoT system may be connected. So there you don't need any cloud also. Okay. Yeah, but as I told you, in many of the cases, you need some storage media through which this data can be stored and processed. And typically, cloud is the fundamental source of storing and processing the data. And here, in that context, let me introduce two important approaches how cloud and IoT are really actually integrated. So first approach is cloudifying the IoT, where IoT weaknesses can be combined with the strengths of the cloud in the form of services, so that all the cloud strengths can be provided as service to IoT systems. So to give an example here, typically the IoT systems are real stuff, and these are small objects like sensors, they are having very limited resources. As I told you, storage, processing, memory, everything is limited in nature. And the most important problem is that they are fail sensitive. The failures are very, very high, and they are highly unreliable. And on contrary to that, if you see the cloud environment, cloud systems are typically virtual stuff, and they are having big objects like servers, and resources wise they are almost like unlimited, infinite resources. Like any number of servers you can keep on adding to your like now algorithm, so that like uh, it's a financial barrier that stops. Otherwise you can add any number of like cloud system wise, it is not having any obstacle, right? Memory, storage, processing, in any context you ask cloud, I want this, it will provide you. Okay. And all of them are reliable and fault tolerant. So even you know that in the cloud, typically the servers are triplicated. So even if one server fails, there are backup 2 servers which immediately take over and continue the services. So that's why the failure rates are very, very less, and that is the reason why they are highly reliable. So we can notice that from this slide, the IoT systems are having a lot of weaknesses that can be compensated with the strengths of the cloud. So in the form of virtual environments. Okay. So that's what exactly we are doing here. We are calling it as cloudifying the IoT. So IoT systems are combined or integrated with the cloud so that their weaknesses can be compensated. So all the IoT subsystems, systems, and environments, everything can be abstracted in such a way that these abstractions can be virtualized, and these virtualized environment can be like provided from the cloud. And IoT systems are having a lot of heterogeneity, different types of sensors, different types of processing capacities, different types of infrastructure. So that differences in the infrastructure, that heterogeneity in the systems can be compensated by the infrastructure as a service provided by your cloud. And the service level agreements can be used to provide any interoperability issues, and security privacy issues can be dealt by using the security as a service provisioning from cloud, antivirus as a service, security as a service. There are many services from the cloud which you can actually use to compensate the weaknesses. So I cannot run complex security algorithms on the small scale processing systems that I use in the IoT systems. Instead, probably I'll send all this data to my cloud, and cloud processes the data, and it analyzes if there is any security flaws in the data it is producing. Okay. Yeah. And as I said, that large amounts of data is produced, and this large amount of data requires processing of data, processing, pre-processing, managing, storing, many things it requires. And all that can be done with the help of data as a service model from the cloud. And the IoT specific applications can be developed using platform as a service, and specific software that are developed in the cloud can be deployed on the IoT systems. So their software as a service models can be used. So there are every corner of your cloud can be actually integrated with IoT systems to help us to implement the IoT systems in more efficient manner. Swati, can you please mute yourself? The other side of the coin is IoTifying the cloud, where your cloud can provide IoT systems as a service. Like one typical example is sensor as a service. So you can create several virtualized sensors. Let me repeat, you can create several virtualized sensors, and these virtualized sensors can be repeatedly used by multiple applications. A broader example is your weather forecasting example, where in a city, there is a weather forecasting station, and that weather forecasting station is like, producing a lot of sensory data, and these sensors can be provided as virtualized weather forecasting sensors. Then that data can be used by multiple other sort of applications. For example, that data may be used by the aeroplanes, or air traffic control systems. That data may be used by your mobile phones. That data may be used by many other similar applications. So just one sensor, which is actually produced from your weather forecasting sensor, we made it as a service, sensor as a service. Then that service can be used by multiple applications for different purposes. So that is the beauty of IoTifying the cloud. So these are the two important corners which indicate that importance of cloud and IoT integration. Okay. So that's the basic ideology behind IoT systems and cloud systems. And there are many open issues in IoT research itself. Okay. So those students and faculty who want to pursue their research in the form of your PhD, or maybe in the form of BTech project or MTech project or internship or any whatever it is, right? There are a lot of opportunities from IoT systems that you can actually use them for your research purposes. So you can actually develop several application layer protocols, or you can also develop several IoT applications themselves, as we discussed, smart healthcare, smart agriculture, different applications we discussed. And typically energy management is one of the biggest challenge in IoT systems, because most of the IoT systems depend on battery power. And battery, if the processing takes if the algorithm runs for longer times, and if the processor is not sleeping at all, then the battery consumption will be very high. So energy management in terms of algorithm design, in terms of battery power management, in terms of communications, like many aspects, energy management is one of the crucial aspect in your IoT systems. So there is a lot of research going on in energy management towards IoT systems. And data management, data dissemination, and data aggregation, like a lot of data centric requirements are there. And most of you are all data scientists these days. You must have learned Python or programming, and a lot of machine learning algorithms, data science mechanisms. Okay. And all that are really needed. And as we have seen few minutes back, there is a huge amounts of data growth, and this data growth requires efficient management of data as well. And that's where we need efficient data scientists who can disseminate the data efficiently, aggregate the data efficiently, process the data, provide some efficient predictions. So these are all several challenges that evolve over a period of time because of data evolution. So we call this as data explosion, and this data explosion will be there due to IoT systems, and we have to address these data explosions for a period of time in an okay. Yeah, other aspects are like, security, load balancing, and service differentiations in the context of your cloud, and naming and forwarding. This is another biggest challenge actually. A few minutes back, I was talking about IP addresses. Armesh, I'm in some meeting. I'll call you back after 9:30. Okay. Okay. So IoT systems, as the number grows, the IP addresses become like obsolete at some point of time. We know that IPv4 itself is a shortage, and that's the reason why we talked about IPv6, but soon the IPv6 may also become obsolete, and the number of IP addresses may become shortage, and people are thinking about fixing this issue with the use of names instead of addresses. So naming and forwarding is one of the important research domain in the context of IoT systems. How the addresses are, how these IoT systems are addressed, and how the packets are forwarded using these names, okay, instead of IP addresses, is really a big research domain. And how to synchronize all these IoT systems is also another big research domain. So these are all like, really interesting research areas. I always suggest everyone to spend good amount of time to understand these topics, and at least take one of them as your research interest, and pursue some project in that. Yeah. So any questions up to now? Maybe I'll open the forum for the discussion for 2 minutes.
If any of the participant is having any question,
Is there,
the house is open for the question.
were there any questions in chat box? I could not see that. I think no questions in the chat box. All right. So these are all basics. I know, like you all must be mastered by now. So let me quickly jump into the next part. We'll talk about cyber physical systems now. Okay. So cyber physical systems is minor extension to your what you call IoT systems. Excuse me, sorry. So here we talk of what is called IoT as an instance. Let me repeat, an instance connecting several devices that may produce data streams, and that may work on different applications or whatever it is, right? But it is one instance. Let's imagine that there are several instances of it, and we need to create some environment or a complete system that uses these IoT instances or IoT notions in such a way that they provide a complete system which will conceptualize, realize, and assure all aspects of this composite system made up of sensors and data streams as the components. Okay, so cyber physical systems is still IoT system, but it is a set of instances, right, that together make it as a composite system or composite system. Okay. So here the word conceptualization is something it's about like what do you say, how these IoT systems are here IoT systems means IoT instances. Okay, so maybe I'll introduce one interesting word here. It is a system of systems. So cyber physical system is a system, complete system, made up of individual IoT instances, and IoT instances themselves are one system. So it is a system of IoT systems. Okay, that's how you have to take it. So you have to, like, in that perspective, you have to consider these IoT systems as objects, and all these IoT systems are interconnected, and they are to, make sense for some, objective, and we have to understand their behavior, we have to understand their purpose, and what is the connectivity between them. This is all about understanding about the integration between these IoT instances, and creating composite system. So cyber physical system is all about that. Okay, and of course realization means it's the implementation of those objects which we conceptualized, we imagined, different objects and different IoT systems, and then we are implementing them. We are trying to interconnect them. We are trying to provide communication between them. We are trying to run the applications. Okay, we are trying to manage the data, process the data. So several things happen in the background in the form of implementation. So that's the next level of implementation. And in the final way, assure that they actually function in the end. So you actually implemented it, but tomorrow it may not function at all, right? Maybe because of this integrity challenges, maybe because of security issues, maybe because of several other challenges, right? And as we all know, these are all producing huge amounts of data, and confidentiality, integrity, availability, authorization, these are all important challenges that are connected with this security challenges connected with IoT systems, and particularly cyber physical systems. So you have to assure that the system functions in spite of all these challenges. Okay, so that's why it is a cyber physical system is a complete system of systems, or IoT systems. Okay. There are many examples, like elevator example. The car, self-driving car is wonderful example for that. So it is having a lot of individual components themselves as IoT systems, but together they should function, right? This is what exactly I mean by the word conceptualization, realization, and assurance. Okay, so you designed a self-driving car. Conceptually, it is working fine. Okay, conceptually, it is an excellent idea. There are what are the objects that are there, how they are interconnected, everything about it. And finally, you implemented it. Okay, that means you realized it. So the car is running on the roads. But the question is, can it run on the real roads? In test drives, it is working fine. Will you be able to assure the running of the same car on the real roads? Particularly the Indian roads case, right? So can you assure that on Indian roads? So that is assurance. If you can assure that also, then this is a complete system, complete cyber physical system, and it is in the market. It will come into the market and it will be ready for use. So it is a complete CPS. That's what it means here. And in the similar lines, you can think of a complete transport system, for example, like connected buses, connected cars. All of them will use the data collected from their experiences. They share and they help each other to improve the transport mechanisms. And in similar lines, there are many examples. Yet another interesting example is automated or integrated operating system, operating theater. Okay, operation theater, where you can connect all medical devices in such a way that they perform the operation by themselves without involvement of the doctors. Okay. And many other examples, smart power grid systems, unmanned aerial vehicles, UAVs, right? Drones or autonomous vehicles, self-driving cars, as we discussed, right? So these are all typical cyber physical system examples, which are really, really going to impact the human life like anything in the future. Okay. So the broad definition is that, and now let us formally understand what are its characteristics. So as I told you, it is having two components. One component, cyber system, which involves the capacity, the connectivity of physical components, right? That may be connected wired or wireless, and maybe having a lot of networking at multiple and extreme scales, right? So this is all about cyber system, which is all about connectivity and management of those things. And at the second stage, you are worried about system of systems. As I told you, system of IoT systems is a composite CPS, right? So in this case, you have to consider both spatial constraints as well as temporal constraints, right? And complex, like, both temporal, spatial scales at multiple levels. And as I told you, they have to have a lot of automation within themselves. So they should be having capabilities to dynamically reorganize, reconfigure their own systems without involvement of the human beings, right? And typically in some cases, there may be some computational and physical substrates like biotechnology systems or nanotechnology systems, right? These kind of future technologies may be involving these IoT systems, biotechnology, nanotechnology, all these together, like, make up. We are also talking about quantum computing. So all these new computational and mechanisms, along with these physical systems, make up new kind of system of systems, which may be totally unconventional in nature, and that may like, lead to new era of computing, new era of science, new era of human life. And it may be having different types of interactions, like in terms of computations or in terms of communications or control. Okay, they require high degrees of automation, control loops, right? And large number of non-technical savvy users will be there in the control loop. So the systems should be automated as much as possible, so that their involvement will be very less in nature, and as much as possible it should be ubiquitous in nature. Okay. And automatically security and privacy requirements are considered even in the case of ubiquity, right? And all operations must be dependable and certified in some cases. And these are all, like, typical examples we have already discussed in the past two slides. So these are, like, points I am trying to emphasize again and again, that cyber physical systems are going to change the human life. Okay. So just to quickly summarize how cyber systems, physical systems actually work. So you can notice that. So here there is an arrow mark. Okay. And there are, so this is the scope of IoT systems, which includes, like, there are several sensors. Okay. And there are several actuators. In between, there are many things happening. There are physical interactions, there are logical interactions. Okay. Physical interactions through your network communication channels, maybe wired or wireless, right? Data aggregation and computations, decision making, several things are happening in between. Okay. And all these are typically called model of motion, and they are working in between your sensors and actuators, right, which are eventually taking some decision and creating some activity in the end. Okay, so this becomes one complete system from sensors, the communications, aggregations, computations, decisions, actuations, the light glows. So all this, becomes one complete system, and this system is a IoT system, one instance of IoT system. And such IoT systems combination may become a smart grid. Okay, where this one light glowing in your home from one set of IoT system, and another IoT system may be in working for another home or another light, whatever it is, right? All such combinations make up to a bigger system called cyber physical system. Like one typical example is your smart grid system. Okay. Yeah, often when you are talking about cyber physical systems, you also need to talk about safety, performance, interoperability, and many other issues. Okay. So when you're talking about safety, make sure that all such systems interact with the environment. System failures can have catastrophic consequences. You have to consider all of them. System correctness depends on both logical results as well as time at which results are produced. So the real-time data. So all that should be considered. If they are not as per the expected timelines, those lead to missing of the deadlines. And once they miss the deadlines, sometimes the system may fail, or that system may lead to some sort of catastrophe. And of course, over and above the safety, you also need to consider the performance. You cannot compromise on the performance also, right? Sometimes it may lead to cost of you need to compromise on the cost. It may not be economics, right? And as I told you, there are multiple IoT systems are working. So this IoT system 1, IoT system 2, IoT system 3, there are multiple IoT systems are interconnected. So they need to talk to each other, and it is often possible that one IoT system is designed by you, another IoT system is designed by me, another IoT system is designed by somebody else, and at the end of the day, the produced 3 IoT systems, if they are not interacting with each other, then it is useless. Okay, it cannot contribute to the full-fledged cyber physical system. So there must be efficient, effective interoperability between all these IoT systems, or you can say subsystems. Okay, and as much as possible, they should work on open standards, open protocols, so that the integration and interoperability becomes quite smooth and simple. Okay. Otherwise, you go with your own proprietary protocols. I design with my own languages and my own protocols. Then it may not end up with accurate outcomes. Yeah. So that is the basic essence of cyber physical systems, and that is really, really going to change the world in the future. And that's the reason why government of India is investing lot of amount on the cyber physical systems. Okay, now between these IoT systems and cyber physical systems, few minutes back we talked about cloud systems. Okay, and we talked about cloudifying the IoT and IoTifying the cloud. These are all different combinations of IoT, cloud, and cyber physical systems, and their combinations produce a bigger level use cases that are really useful for the mankind. Okay, at the large scale. So that is the goal of all these systems. But the big challenge with these systems is that since the IoT systems communication capacities are also low, computational capacities are also low. That's why we are using cloud computing. But because of that reason, the IoT systems sometimes may not be able to produce the outcomes on right time. So many of the operations may not be real time in nature. So that is where we talk about new kind of computing called edge computing or fog computing, a subset of cloud computing that contributes between IoT and cloud, or that sits between IoT and cloud, and that gives many benefits to IoT systems. And you can think that this edge is a small cloud, or you can say part of the cloud. We brought it and kept close to your IoT system. So let's this figure can better explain you. So this is your cloud, and these are your IoT nodes. Okay, hope you're able to see the picture and my laser pointer. So in between these two systems, you can have small clouds, which you may call sometimes fog nodes, some other times edge nodes. Okay, and which are very close to your IoT nodes. They are very nearby to your IoT systems. What is the advantage of this? Let us see. So edge computing is a distributed cloud computing. Let me repeat, it's not simple distributed computing, it is distributed cloud computing. I stress the word cloud here. Okay. So distributed cloud computing technology, so it uses all the technologies and principles of your cloud computing, like your virtualization, scalability, pay-per use, so and so models, whatever that are there in the cloud. Okay, yeah, but they form the subset of your cloud in such a way that they are deployed in close proximity to IoT devices, and typically on the continuum of your IoT device and cloud. So this is the continuum of IoT device and cloud. Okay, this is cloud and this is IoT device, and this is the line. This line is the continuum. Okay, on this line, somewhere close to your IoT device, close proximity to our IoT device, you just deploy a small cloud which performs the similar action like your cloud. Okay, then the operations are performed very close to your cloud. So historically, in the olden days, when this research started, the concept of edge computing, though the term edge computing is coined, fog computing is coined recently, but the research started way back in 2012-13, and fortunately, one of my PhD students also started researching in this direction, and at that time we called it as cloudlets. So please note that, remember this word cloudlet. Sorry, in couple of slides, in the coming slides, I will be using this word cloudlet. Typically, it is similar to your edge node. Okay. And at that time, the cloudlet term was used in the context of mobile devices because during that time, IoT was not popular. So only mobile phones were popular, and Dr. Preeti, can you please mute yourself? It's been done. Thank you so much. So at that time, the cloud computing was.
Participants are requested to kindly mute themselves.
Dr. Preeti, can you mute yourself, please? Dr. Preeti.
Sir, she is muted. I have muted her.
Okay, great. Thank you so much.
Yes, sir. Sorry
Sir,
for
can we make all the participants except the speaker in mute mode?
Yes, sir. I'm asking Kuldeep to do so, sir.
Okay.
Okay, sir.
No issues. Like if they want to ask the question in between, they can ask.
Sir, there will be a discussion session after this talk.
For that, they can raise hand. We will unmute them.
All right. That works.
Yes, sir.
Okay, sir. You can continue, sir.
Yeah. So At that time, the integration of cloud was only with the mobile phones, and we were also working at that time in that direction. So during that time, the idea of introducing small clouds, which are called as cloudlets, in the continuum of mobile device and cloud, to give better services for the mobile devices. So later, the idea evolved into fog edge computing. Later, the mobile centric cloud computing evolved as mobile edge computing. So there are different terminology floating in the literature, but more or less the principal idea of all these is same. They are the distributed cloud computing environments to provide the services in close proximity to the mobile or IoT device, whatever you call it. Okay. So that's the basic principal idea behind this edge computing. Okay. Yeah, the main advantage of these edge computings include the major advantage is low latency computing, where whatever the processing is there, that used to the data used to go to cloud, process it here and come back to your device. So that takes a lot of communication time. And note that the communication cost is much higher compared to computation cost. The big challenge with the IoT device is that they are dependent on battery power, and the communication cost consumes huge amounts of power. So there is always a question whether to send or offload the data into cloud or not. Okay, because the communication also costs, right? So that's why there is a big research going on to optimize this communication cost, as well as computational aspect, considering computational aspects, battery power, and many other aspects. Okay. So one big advantage is low latency computing. So quickly the results are produced nearby from the nearby device. So that's why they can take quick decisions. And these kind of fog nodes will help in the future by connecting your cars and traffic signals, CCTV cameras, and other the driver who is using mobile phone, like several things, and maybe your home computing system, multiple systems maybe acting on same single particular application, single cyber physical system. Okay. So another advantage is the resources are localized. Now earlier resources were there in the cloud. Now they are localized. They have come close to your devices or IoT devices. And most of the data is processed locally now in the fog nodes. So in the olden days, whether it is useful data or unuseful data, every data is stored in the cloud, and unnecessarily lot of storage is becoming waste and unused. So unless cloud is not cheaper, right? It is it's some cost. So that's why this data explosion into the cloud can be avoided or minimized with the help of fog nodes. Why? Because all the data, whatever you are sending from the device, can be first processed in the fog node, and only meaningful data is sent into the cloud for further processing or storing purposes. So this is how we can actually deal with a lot of network traffic as well as data explosion. This way bandwidth can be saved, data explosion problem can be solved. There are many other advantages we have. Okay. And apart from that, it adds it works like your caching mechanism, right? L1, L2, L3 cache. So this cache helps to localize the services. Similar way, the fog nodes act like your caching nodes. So they localize the services here. Okay. So locality of reference you might have heard of this word, locality of reference, in your cache concept. So the challenges what you face in your caching mechanisms like cache coherence, similar way data coherence problems will be there. So all that will be there here, and you need to rethink about all these problems in a different perspective. But advantages wise, this is very quick in providing the services to the IoT devices, which are short of resources, and edge computing provides the resources by sitting close to these devices. That's the beauty of edge computing. And there are many again challenges, particularly research challenges in your edge computing side as well. This requires new type of architecture design, framework designs, service provisioning mechanisms. Now you need to partition the application. Like for example, part of the application might need to run on your IoT device, some other part might run on your edge node, and probably some other part maybe on the cloud node. Okay, so it requires, like, not the just single application that can work for all the three. Instead, you need to partition the application into 3 components or maybe 2 components, and like different components are running at different environments. So by introducing the edge computing, you need to think about a new way of designing the applications also now. And you need to offload the tasks, like part of the application runs on IoT system, part on your edge computing, and as a backup, you're always having the cloud. Okay. And sometimes you need to discover the edge nodes so that you can actually, like, suppose one edge node is not working, then you can transfer it to the other edge node. Okay. And there are many other similar examples and applications, like this will improve the user experience and quality of service. And you need to do a lot of research towards how to provide real-time services and how to deploy the workloads. What are the strategies, policies, what node characteristics you have to consider, whether there is a load balancing or not. So there are many things that come into the picture, right? Yeah, and apart from that, security is also another big challenge. Real-time data processing is also another big challenge. Not only provisioning, data processing, both are important, right? So these are all like new challenges that leads to opportunity for you people to pursue your research. Okay, any questions up to now? You can raise the hand. Or type in the chat box.
Participants can ask anything if they want. They can type also in the chat box.
All right, no worries. So, looks like there are no further questions.
Sir, there is one question in the chat box from Nisha Sani.
Can you please read it for me?
Yes, sir. Can edge computing and fog computing are the same things?
Oh, okay. That's interesting question. Yeah, actually, this is only there is only the difference in the perspective with which we see them. Typically, most people use these two words interchangeably, and some people will use both the words with different perspectives. Okay. So in what context you are using these two words is important. Now, let me simplify that statement. Fog computing is often used in the context of cloud computing, the sub-cloud, what I'm talking about. Okay. And edge computing is talking about, like, producing the servers close to your IoT system. Actually, both are in the close proximity to your IoT systems or mobile systems, but typically people sometimes use it as 4-layer environment: cloud, fog, edge, and IoT systems. Often you don't need these many architectures, but typically some people will use it like that. But in the that depends on what context you are talking, but in general, these two are often used interchangeably. That's very good question, interesting question. Yeah.
Kavita, there is one more query in the chat box. Can you read it? It is from Rakesh Mittal.
Yes, sir.
Is there any service provider like AWS who provides services of edge computing?
AWS itself provides the service of edge computing.
Okay. It provides both the services of edge computing as well as the cloud computing.
Yes. Fog computing also.
Okay. Okay.
And many other, like all providers, like Microsoft, Azure, Google Cloud Platform, GCP, and your AWS, all of them will provide like edge
Sir,
computing.
can I ask something?
Yeah, please go ahead, sir.
Sir, is there any criteria or guidelines for which type of applications we should go for edge applications, or for which type of applications we should go for cloud applications?
The guideline is quite simple. The simple is, if the system, IoT system, is not capable of performing the computations locally, and it is having scarcity of resources, then it has to borrow the resources from some other source, and that some other source is your edge computing and our cloud. That's the point here. So the designer of the application decides whether to go for edge computing or not based on the resources requirement of that IoT system.
Thank you, sir.
Maybe I will give a interesting example that might help you to understand. Let's take this picture. Let's assume that for a minute, these are all your laptops or mobile phones. And let us also assume for a minute that we are all sitting in a classroom. Okay. Though we are sitting in your residence, but let's for a minute assume that this is an offline session and we are all sitting in a classroom. Okay. Now, there is a India versus Australia match going on. Let it be a final version, or there is a India versus Pakistan match going on. This is some World Cup final. Okay. And Dr. Kavita is curious to conduct this course. So she involved in this program. She don't want to compromise on the dates. Now, all the participants are, let's say, our students, and they are sitting in our classroom. Now match is going on. They have to attend this course. Dr. Kavita will not give the attendance. Okay. So what the participants will do, what the students will do, they will watch that cricket match from their mobile phone. They'll keep the phones on the desk or somewhere or other kind. They use some tactics to escape from you, and somehow they'll try to watch the match. Just to imagine all these things, what is happening in this case? Now I'll give another similar example. Let's suppose that we are all in a mall, a big mall, match is going on. And many people are watching the same match from their mobile, from the same mall. Okay. And all of them are connected to more or less to the same, the cell tower. Okay. Let's take third case study. There is a railway station, airport, or bus station where huge crowd is there. And again, the people are watching the movie or match, whatever it is, right? And they're all connected to the same, mobile station or the tower. Okay. So what is the context here? If there are 100 people in the classroom, if there are 1,000 people in the station, okay, then they're all contacting directly to the server. I guess you all must be knowing that these cricket matches are streamed through your OTT services, for example, and OTT services are typically the cloud services. So you are not actually directly getting this cricket match, you are getting the cricket match from the cloud, from their cloud. Okay. So simplifying the discussion, now your 1,000 people are contacting the same cloud at the same time. So what is the disadvantage with this? 1,000 requests are going. So 1,000 times network bandwidth is congested or made busy, and 1,000 times your cloud is becoming busy. The Netflix cloud or Disney Hotstar cloud, whatever it is, right? So that is becoming crowded now. What is one of the fix for it? You deploy a small Netflix cloud locally on your bus station, locally on your airport, locally on your railway station, locally in your classroom. Then all these thousands, hundreds of requests will go only to your local cloud, Netflix cloud. And from there, only one request will go to the main cloud. So the main cloud and your local Netflix cloud is the fog node. Main cloud is, of course, the actual Netflix cloud. Okay. And all your devices, these are all devices, let us say, and this is your local Netflix cloud, and this is your main cloud. Okay. So you're getting services. Earlier, if there are, let's say, 6 devices, 6 requests are going. Now in this example, only 3 requests are going. Okay. And under this single fog node, let's say there are 100 nodes. So earlier 100 requests are going from this direction, and there are 1,000 requests from your railway station, let us say, and another 1,000 requests from bus station or airport. So now what happened here? Only 3 requests, and internally you got 100 plus 1,000 plus 1,000 requests. So this way the load on the cloud reduces and the services become more efficient. So that is the beauty of edge computing, which based on the application and application requirements, we decide whether to deploy a fog node locally or not. Hope it is clear now.
Sir, good evening, sir.
Yeah, please.
Hello, am I listening to you, sir? Good evening.
Yes, you are audible.
Yes, sir. Yes, you are audible.
Sir, can you tell me the major security concerns of edge computing? What are the recent trends or areas where we can move for the research?
Yeah, that's another very good question. I just made it a broad statement here, security in public edge nodes. Okay. But these edge nodes can be public as well as private. Okay. So if they're private edge nodes, typically these private edge nodes are deployed in public places. So the security of these, physical security of these public edge nodes is always a challenge, like your other systems. Okay. But apart from that, these edge nodes computational capacities are relatively low, and IoT systems are very much prone for security flaws. So security attacks. So attacker can try to intrude into edge computing nodes through IoT systems quite easily. Okay. So that's why edge nodes should have different perspective of dealing with these security mechanisms for the data that is coming to your edge systems. Otherwise, earlier the data was going to cloud, now it is going to edge computing. So whatever the previous challenges were there, the same challenges would exist for your IoT edge continuum related security challenges. So, but here man in the middle kind of attacks are much high possible compared to the previous case. Hope it is clear to you.
Yes, sir. Thank you, sir. And sir, what is the role of this edge computing to improve our health services? Is it possible to improve health health services, health related services with the edge computing?
Yes, absolutely possible. In fact, we wrote a proposal also recently around this to design a edge node for health services. And yeah, you're absolutely right. It is possible. So
Thank you, sir.
like in
Thank you,
your,
sir. Thanks a lot.
in your hospital, you deploy, let's say, for example, Apollo is having chain of hospitals. Okay. Then all the Apollo hospitals will have locally the edge nodes, and globally they will have the cloud. Yeah.
Thank you, sir. Thank you for this valuable information. Thank you. Thanks a lot.
Great. Great. So it is done, right?
Is any other participant who want to ask something to sir? I think there is some query in the chat
Yes,
box.
from Mamta Kumari.
Okay.
Can you please suggest some IoT tools in agriculture?
That depends on the application what you are designing.
Sir, are there some tools available which you can name?
That's what, sir, like, it all depends, it totally depends on what application you are designing.
Okay.
Mm.
As per our requirement.
As per our requirement, yes.
Mamta, can you elaborate your question if you are listening? I think she is not able to listen. Is any other participant with any other question or query? Sir is kind enough to answer your queries, or you can mail to him.
The next question is some research gaps in IoT agriculture.
Open areas for research.
Like, for example, easy technique, I'll tell you. Deploy edge nodes in your IoT systems in agriculture. For example, I just want to share one slide with you. Let me see if I can do it. Now,
Sandeep, can you mute yourself?
Sir, I have muted him.
Okay, okay.
Professor Sateesh, double click to enter full screen mode.
first, let me share. I mean, is it being shared?
No, sir.
That's why I just.
It's
wanted-
again showing the message that has started screen sharing.
Okay. Let's stop and do it one more time. Is it any better now? is the problem for this?
Yes, sir. Your screen is visible.
Visible, right?
Yes, sir.
Okay, nice. So I think you told me Mamata, right? That name?
Yes, sir. Mamta.
Yeah. So Mamata, this is one of the algorithms we designed in our laboratory, okay, for data acquisition. And suppose this is a prototype we have created in our laboratory where we used different agriculture related equipment, okay, and we deployed in the real-time environment to monitor the environmental factors, and we developed some algorithm for that. I mean, this is all okay, and then we analyzed the data. The question is it all depends what is the purpose for which you are doing. Okay, so based on that you can actually decide what are the parameters you consider, how they do it. For example, how many number of nodes you want to deploy, what is the cluster at which you want to do, what are the energy factors you want to consider. Many things you have to consider in your development case. Like this is the energy model we designed for that. Okay, and we performed several machine learning algorithms to analyze the data. So we also tried some security aspects in that. So we introduced some malicious nodes in this environment, and we developed some edge computing nodes. We deployed some edge computing nodes between users and your cloud environment. So for that, we used several IoT nodes in the real-time environment, took several IoT nodes and some Raspberry Pi based edge nodes, and we connected them to perform the analysis. I mean, you can think of several ways. This is one case study I was talking about, how we use it. So it all depends where you use it, how we use it, right? And what is the application for which you want to develop it. Based on that, you decide what is the purpose you want to do it. And that also depends on what algorithm you are developing. Suppose if algorithm is developed for IoT, like processing the data locally in IoT system, or is it being developed for transmitting the data from IoT node to edge node or cloud node, or is it the communication related thing, or is it, so several factors that decide what environment you want to choose. So hope it addresses your answer, Mamita.
Okay, sir. Thank you so much.
Yeah, great. So how much more time we have? So this is one of interesting case study that everyone can think
So
of.
we are having 15-20 minutes if something in that you want to cover.
So let me check my luck again. If I can connect my slide. Probably I should have discussed the same example case study. Sharing is becoming difficult. Is it shared now?
Yes, sir.
Oh, thank
Sir,
you.
it's visible.
Thank you so much for confirmation. Full screen?
Yes, sir.
Nice. And probably Mamata also was asking about research gaps. I think this word she used, I guess.
Yes, sir.
So in the context of agriculture, if you are talking about research gaps, let me say, just to simplify the answer, maybe see, agriculture involves the supply of the water on right time. Okay. Agriculture involves supply of the, I mean, water, light, I mean, those like, parameters which make your plant to grow. So understanding, analyzing these parameters like soil dynamics, leaf dynamics, plant dynamics, okay, monitoring and understanding them and analyzing them, based on that take some decisions, is one aspect where you can think of doing research. Another aspect is leaves often, like, they become dry. This dryness may be because of these parameters weakness, or the dryness may be because of some disease attack. So you should be able to analyze based on the leaves characteristics whether it is a disease or not. If it is a disease, what sort of disease it is, and what measures you can take to overcome this disease. Okay, is another big area of research. Okay. And recently we wrote a research proposal about in this direction, and like, I'll give you a big picture of it. In the areas of Uttarakhand, Himachal, like where hill stations are there, okay, their soil dynamics are different, and that is the reason why you cannot produce all the types of crops. Okay, so choosing the right crop for a particular soil is also one interesting application domain, right? So there are many ways you can think of. These are like, interesting things I quoted, where you can expand your scope and start working around it. And a lot of research is already there in this direction, and you can of course think about several other directions as well. And if you are not comfortable with real-time implementations, as we did in our laboratory, you could think of doing in some what is called simulation studies or emulation studies. Still will work. Okay, there are several IoT simulators. There are several fog simulators, cloud simulators. So use all those simulators and implement your ideas first. And once your algorithm is working fine, then better go for real-time implementations. And these days, the IoT systems are not such costlier. Like Node MCU comes at the rate of maximum $500 of Indian rupees. Okay, and all sensors 5 rupees, 2 rupees, 10 rupees. I mean, such a less cost it is. So even if you spend 4,000 to 5,000 of your personal pocket money also, you could produce excellent research from your home. Such easy it is nowadays to perform the research in IoT systems. Okay. So I hope that gives at least some motivation to you and others to start research in the direction of IoT. And your laptop can work like your edge computing node or cloud computing node or some processing node. Okay, sync node. And your Raspberry Pi, which comes around 5,000 rupees, 3 to 5,000 rupees. Okay, can be your in between node, like edge node or fog node. Like you can think of several ways to create an environment of this kind. And like, even if you are spending Raspberry Pi, hardly you have to spend 10,000 bucks from your pocket. So that's cheaper it is. I mean, 10,000 is not something like your pocket money. Just you save it for 1 month, but you can produce very good number of research papers from that. So that is the advantage with this IoT centric research. And may it be agriculture, may it be smart home. Like, see, I'll tell you a lot of examples in that direction. Like our students, from their pocket, they invest and they produce a very good number of products by virtue of their hobby. We are having a hobbies club in our campus, and in the hobbies club, one sub wing is electronics division, another sub wing is software development section. So both people mix it together and produce very good set of IoT centric devices, like automatic music playing systems, automatic toilet cleaning systems. I mean, otherwise there are many other examples like the automated cars or rickshaws. Those examples are already there from long time, but people are thinking innovative ways to create the systems where the human beings feel inconvenient or not accurate or efficient or doing these things. So you can produce these kind of several outcomes, efficient outcomes, by virtue of IoT systems. So that's why I always recommend doing a very good research in IoT systems, and that produces data, and this data you can use it as a test data. And there are a lot of data available in the internet that you can use it for training purposes and use a lot of machine learning algorithms. You don't need to code these days. All the machine learning algorithms codes are available on the internet. Just it's a plug and play. You are already having data sets. What you are doing is you are producing a test data from your created environment, and this test data you are analyzing using the model you developed using trained data. I mean, simple strategy that helps you to develop a very good working environment from your end. Hope this approach works for you and helps you.
Thank you so much for suggesting such a good idea, sir. It will really help me.
Perfect.
So one more thing. Can you please elaborate the case study you were showing in your slides? The agriculture study. You were showing the device on the trees.
No,
If possible.
No, that's not possible.
Okay.
The reason is, otherwise I would have presented that work itself. We communicated that paper. We have not yet published it so far. Okay. So that's why I don't want to spend long time on that.
Okay, sir.
Even I request Dr. Kavita not to share that part of the section with anyone. Like, don't publish it anywhere.
Sure, sir. Sure.
Okay, sir. Thank you so much, sir.
Yeah.
Greetings, sir. Manoj Pawar this side, sir. Can I add to this, sir?
Yeah,
like from the planning perspective, as a planner, we require the amount of crop or the quantity which is going to be coming to the market at a particular period of time. So by studying the phenology of the crop, we can actually identify that how much crop is coming at one particular time. So we can actually plan the capacity of all these mandis that we are having, the markets that we are having, so that we actually do those kind of things through IoT as well. Like we are doing this through the drone surveys and all those things.
Yes.
We are capturing the data at a particular period of time. Let's say after 15 days, we are capturing almost, let's say, a district data. In Haryana, we are having a drone project by the state government of Haryana, and we are doing the same kind of thing by using that. So can we actually do that thing by using IoTs, or are they IoT? Because I'm from a planning background and not from computer or electronics background, so I'm unable to understand those kind of terminologies. So can we actually do that kind of thing by, let's say, deploying small IoT devices in fields?
Yes, absolutely right. Thanks a lot, Dr. Manoj, for this important topic, raising this important topic. one of our BTech student, though we are not having like financial support for this project, so that's why we are not doing in real time. At this moment, we are doing it in simulations. We are working on a project called Internet of Drones. So in your Monday, you can deploy large number of drones, and you can make these drones to talk to each other, and these drones can work like your edge nodes. So like there is a lot of research scope towards that. So crop monitoring, drone monitoring, and then edge computing, IoT systems, all these can be mixed together to produce an excellent research domain. Yeah, you're right.
So that will save the amount of data. These different organizations are basically conducting surveys for that. So by using the same instrument, we can use multiple departments can use the data.
Absolutely correct. Absolutely
Okay.
correct.
Thank you very much.
It will be more accurate, more comprehensive, and aggregated. So hope we are on time now.
Yes, sir. Any other questions from the participant side?
Kavita, I think we had enough discussion. It was really a very good session on IoT and fog computing. I think we can conclude the session now.
Yes, sir, sure.
Great.
So thank
Yeah.
you very much, Professor Sateesh, for such a subjective and informative talk. My gratitude to you for accepting our invitation to deliver this expert lecture in this FDP. I truly appreciate you and your time you spend for us to be on this FDP in online mode. So the way you have explained all the topics like IoT, cloud, from actual basis is very beneficial to all the participants, as some of the participants are not from computer science background. Cyber physical systems, their use, how they work, and how they are going to change human lives. You provided countless new ideas to upcoming researchers. Thank you very much, sir. I'm fortunate enough to get you on this FTP. Thank you so much, sir.
Yeah, thanks a lot, Dr. Kavita, Dr. Manoj, and Dr. Singh for inviting me for this session. And thanks to all the participants for listening to my talk patiently. And hope my talk will be useful to you at some point of time. Wish you all the best.
Sir, Professor Sukhdeep Singh is my fellow coordinator in this program, and he is also our chairman of computer science and engineering.
Awesome. 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 Nice meeting you,
It
sir.
was really a nice discussion, sir.
We'll meet some other time, sir, on offline mode.
Sure, sir. Sure, sir. We would like to have you. We will enjoy your company, sir.
Definitely.
Sir, actually, I was trying to call you in the offline mode only, but because of your availability, we thought to be with online mode. Otherwise, in the next FDP, next time, whenever we will get a chance, we want to have you on offline mode only.
Definitely, madam. Definitely. I'll be happy to visit your place.
Thank you so much, sir. Thank you.
Thank you so much. So see you then. Good night to everyone.
Good
Okay,
night,
sir.
sir.
Good night. Thank you, sir.